we continue. I want to get back to a question as some of you asked yesterday at the end. And the question was about vaccine against shingles. So as you know, I talk about varicella zoster virus, or disease, which is one virus that can cause both chicken pox in children and also shingles in adult. So there's a vaccine for chicken pox, which is a live virus based vaccine, and that virus is attenuated and less pathogenic virus that we use to inject the babies. So for shingles, definitely there's another vaccine available, but apparently it's different. So the vaccine for shingles is actually a virus protein rather than the live virus. And I call the manufacturers for shingles vaccine. And the reason is that you cannot use, or it's better to avoid using the live virus for shingles vaccine, is because aging people, when you get old, your immune system is going to get weaker and weaker. So even a live, even less pathogenic and a weakened virus can still cause some problem and concerns. So that's why instead of using the live virus for vaccine, they use a virus protein, to boost the immune against the shingles. And I think it makes sense, because when you get old, your immune goes weaker and weaker. So if you inject a virus that even is less pathogenic, it can still, cause some problem. Particularly the virus can get into your brain, so infect your neurons, and it may contribute to aging, particularly some, the brain development. The aging, of the brain. So now let's continue with another very important Turkish virus, which is Epstein-Barr virus, or EBV. And this is a virus that everybody gets it almost. So basically, it's transmitted through saliva. So most of the time, you get it through your parents. By age 6, most of you will get it. And if you don't get it, there's another chance for you to get it. And that is when you get to, when you get it in high school, you will get it from your sweetheart. Because it's easily transmitted through saliva. Okay. And once you have the virus, you're going to have it forever, for the rest of your life. And just like any other herpes virus. And this virus is even more common than other herpes virus, like herpes simplex. The majority of the population are getting infected, they are infected, but surprisingly, most people, because we are, immune competent, so this virus, even when we get infected, we, do not assume any symptom, and the virus is, basically it's asymptomatic. You don't see any symptoms, basically. But this virus is oncogenic virus. It can cause cancer. And let's say if you have a normal cell growing, if you infect the cell with this virus, the cell become actually immortalized, which means it can proliferate without any limitation. So this virus does have the ability to transform the normal cell to proliferate, and it can also cause multiple diseases, and one of the diseases can have is the so-called infectious mononucleosis. Basically, it's like a flu symptom, and you are going to have fever, and also you have a sore throat when you have that, and it takes a couple of weeks for you to recover. Basically, you're going to have a sore throat, and that's the main symptom. Basically. But some some immune suppressed patients without treatment, this kind of disease can progress and to become malignant lymphomas. So it's something you need to be aware of. It's not that everybody can have a lymphoma, but there's a risk, potential risk. EBV is also associated with a very deadly cancer. It's called Burkitt's lymphoma in Africa. Why in Africa? Probably it has something to do with the local environment, because in Africa, malaria is very common, and there's a mosquito. Burkitt's lymphoma is a cancer. So EBV infection is a factor, but then probably it's not the only factor. There's other factors involved as well. As you know, for cancer treatment, it requires a minimum of 3 factors, I mean 3 genes, tumor suppressors or oncogenes, right? So this is true for any cancer. So it requires at least 3 factors or genetic factors, either tumor suppressors or oncogenes. Okay, so for a normal cell to become a tumor cell, you either lose tumor suppressor or you have activation of the oncogenes of at least 3 genes, the tumor suppressor or oncogenes, in order for the normal cell to become tumor cell. So this is true for Burkitt's lymphoma as well. I think what happens, EBV is a contributor, but it requires other factors as well. So this actually is indeed what I see. So in Burkitt's lymphoma, it's well established that if you do a histology study, you will find that most of the time you see chromosomal translocation. Between the translocation occurs between chromosome 8 and 14, 2, or 22. So what happens is when there's a chromosomal translocation between these 2 chromosomes, is that the chromosome 8 has the oncogene, which is not expressed in normal cells. Okay. So when there's a translocation, what happens is after the translocation, this oncogene is going to be placed under the control of a gene called immunoglobulin. So immunoglobulin gene is expressed constitutively in B cells. So when the translocation occurs, after translocation occurs, this oncogene MYC, c-MYC, is going to be, especially for c-MYC, is going to be under control of the immunoglobulin gene. So that leads to overexpression of c-MYC. So basically you will have activation of the oncogene c-MYC. So that will lead to uncontrolled proliferation. So this genetic event certainly also contribute to the development of Burkitt's lymphoma. And so EBV is also associated with another cancer called nasopharyngeal carcinoma, or NPC. And this is also a very deadly disease, cancer, that is extremely common in Asia, China, Hong Kong, Taiwan, basically Southeast Asia. It may have something to do with the local environment or the food they consume or the way they eat, which can drive reactivity of the EBV virus. So this is a very deadly cancer, and what we see in the cancer cell is that you can find multiple copies of these EBV genomes in the cell, okay, and also in the patient's blood, you can find high titers of the antibody against this virus. So basically, and there are some experiments have been done. So if you get rid of this EBV virus from the cancer cell, actually the cancer cell dies. So that means the cancer cells are dependent on the EBV genome in order for them to proliferate. And so what is relevant to you guys is another type of disease called leukoplakia. And this is also a very quite common medical condition you're going to see probably quite often in your patient, in the future in your career. And this is extremely common in those people who are immune suppressed, particularly HIV patients. So what you see is it begins with this kind of white lesions, okay? It's a white lesion in the oral cavity, in the tongue or cheek, whatever. And usually at the very beginning it's not malignant, so it's something you can treat. For example, if you treat a patient with anti-herpes virus drugs, like this oral leukoplakia will regress. So it can get cured. But without treatment, okay, this leukoplakia can progress and then transform into a malignant tumor called, basically it's an oral squamous cell carcinoma, and that is really a malignant cancer, okay, and it's quite deadly. So I think right now, if you go to a dental clinic, they will ask you for oral cancer screening. And this kind of oral cancer is one of the things they're going to check, okay? It's quite common actually. And EBV is also associated with other, non-Hodgkin lymphomas, particularly in HIV patients, which basically it's a B-cell type lymphomas, okay, lymphocytes lymphomas. The reason is because EBV, is common herpes virus, right? So it establishes latency in B cells, infect B cells as well. So that's why, it can is associated with several types of lymphomas. So in terms of diagnosis, usually, if you don't have a problem, actually, you don't need to have a diagnosis. But if you have either type of those kind of cancer or malignancy, or even leukoplakia, you need to have a diagnosis. And the diagnosis is basically the presence of the anti-EBV antibody. Or cancer, you do a histology. If you can see the presence of the virus genome in some kind of cells, and that probably tell you that you have EBV associated cancer, or whether it's a Hodgkin's lymphoma or MPSA. Okay, basically this is how we do diagnosis. Any question about EBV? No. So then I'm going to move on to another gamma herpes virus.
Wait, I have one quick question before you move on.
Yes.
You said that they required a minimum of 3 factors, and you mentioned to lose tumor suppression and activate oncogenes, but what's the third factor?
Tumor suppressors, I'm talking about, third factor means it can be either tumor suppressors or oncogenes. So there are many different tumor suppressors in our body, and there's also many oncogenes, right? So you need a minimum of 3. It doesn't matter whether it's the tumor suppressor or the oncogenes. If you lose 3 tumor suppressors, that's enough for a normal cell to become a tumor cell. Or on the other hand, if you have an activation of 3 oncogenes, they will do the same. Or you have a combination of a loss of tumor suppressor of 1 or 2 plus activation of oncogene, then you are going to have a tumor as well. Okay, so the 3 factor means either the tumor suppressor or the oncogenes. Okay, and that has been experimentally proven, as well established. Okay. No other questions? Okay, so let's move on to the other herpes virus, which is HHV8 or Kaposi sarcomas herpes virus, KSHV. This is a major problem during the 1990s in the US when there's an endemic of HIV infection, but we didn't have a very effective treatment for HIV. So at that time, there's a lot of Kaposi sarcoma. But right now, since we have a very quite effective treatment for HIV infection, even though we cannot cure HIV, but there's definitely anti-HIV treatment. So this type of cancer, right now is getting less and less frequent. It's real, but it's still there. Okay, so basically, Kaposi sarcoma is a malignancy that comes from the blood vessel cells, endothelial cells, after cancer infection. Okay. This virus can also cause several types of lymphomas. Okay, because this is a common herpes virus that it can infect B cells as well. So two types of lymphoma are associated with this virus. One is called multicentric carcinoma disease, or MCD. So basically, this is the result of cancer infection of B cell in the lymph node. Okay, and then we are going to see a proliferation of the B cell in the lymph node. It is a malignant tumor. Okay. And the other type of malignant lymphoma is called primary diffusion lymphoma. Basically, this is also B cell lymphoma, but basically the B cell is not in the lymph node, but in your body cavity. Basically, if somebody has this type of lymphoma, you're going to see they have a bigger value in which they're full of cancer infected B cells. Okay. So Kaposi sarcoma, as I mentioned, is a vascular malignancy. Basically, the virus infects the endothelial cells on the blood vessels. Okay, the endothelial cell is the basal layer of the blood vessel. Right? Blood vessels. I don't know if you guys are familiar with the structure of blood vessels. Not really. Okay, the blood vessel. The basal layer of the blood vessel is epithelial cells, right? And on top you have small cells, and then other type of cells, right? So the virus cancer infects the basal layer in the endothelial cells. So the outcome of the infection is proliferation of the endothelial cells, and also inflammation. So what you're going to see is you see a lot of infiltrating inflammatory cells like B cells, T cells, natural killer cells, and all those different types of inflammatory cells coming into the infected sites, and that will even further contribute to the proliferation of the endothelial cells. What you also see is the blood vessels. So the viral infection further promotes the growth of the blood vessels. So that's why if you do a histology, you see in the tumor, you see a lot of extensive blood vessel networks. Okay, so that's what happens. Basically, the viral infection promotes cell proliferation. Angiogenesis means blood vessel growth, and inflammation, and that's what causes this cancer. Okay. And the Kaposi sarcoma can occur anywhere in your body, in the skin, but it can also in your internal organs, and also in the oral cavity. And so far, there's no cure, and the only cure that is effective, but it's not effective, but it can regress the tumor is the anti-herpes virus drugs that I talked about yesterday. The tumor can regress, but never disappear. So if the patient stops taking the drugs, and the tumor comes back. Okay. Right now, so it has something to do with the immunosuppression. So if the HIV patient, for example, if they are undergoing the anti-HIV treatment, and also in the same time they take anti-herpes virus, drugs, the cancer can be controlled. So far we have talked about alpha herpes virus and also gamma herpes virus. Now let's go to the other group herpes virus, which is the beta herpes virus. So important member of this beta herpes virus is cytomegalovirus, which is the biggest herpes virus. As I showed yesterday, it has a huge genome, almost 350 kilopare bases, including almost 150 different genes. So it's a big herpes virus, the largest herpes virus. And when a cell is infected by this virus, the cells also become much larger. And what you see is you see some kind of aggregates, also called inclusion. So even in the nuclear and also in the cytoplasm. This is a typical phenomenon that you can see when you have a CMV infection. Okay. This CMV is also transmitted through saliva and also other secretion, milk, body liquid, basically. And you can, as I said yesterday, the beta herpes virus, they can target multiple types of cells. So they have a broader range of hosts. And they can get into different tissues. Okay, most of the time they don't cause much harm. This virus is not as pathogenic as other herpes virus, basically. But I can cause some problems, particularly in patients who are immunosuppressed, and also it can cause some problem to newborns and little children. Okay, whose immune system are not well established or developed. Relevant to you guys is CMV is very commonly found in your oral cavity. In America, there's statistics showing that in America, 70% of people have this virus, and it's commonly detected in the saliva. In the 1970s, there was a lot of people believed that CMV may be effective for or contributor to the development of periodontal disease. But right now, we know that periodontal disease is mainly caused by bacteria, right? Gram-negative bacteria, right? But what I think is, CMV infection may be a contributor, but it's not the main cause of periodontal disease. It may, make the periodontal disease worse, but definitely it's not the cause. This is something you may, when you go further, you can ask your teachers. And some old doctors, they still believe CMV is a contributor, but this definitely, I think, is something you need to be aware of. Okay? It can contribute to periodontal disease. And the other two members of the alpha herpes virus, herpes HIV-6 and HIV-7, they are very closely related to virus, and they are relatively new because they were found in the 1990s, and mainly in Japan. It's very rare in America, and they mainly cause some problem to little children, basically flu symptoms, and they can also cause some kind of skin rash. But in general, those diseases are self-limiting and it's not very serious, so it's not a big concern. Okay, so these are the two herpes viruses that they belong to the alpha the beta group as well. Okay. So I think this is what we have about herpes virus. Do you guys have any questions about herpes virus so far? If not, then I move on to another very important oncogenic virus. That is human papillomavirus or HPV. Okay, and let's see. This is a very important virus because it can cause cancer. So before I do any further, I would like to start with, I would like to spend a little bit of time to talk about the virus genome, okay? And basically biology of this virus first, because this is important for you guys to understand what I'm going to talk about later on. So first of all, HPV is not like a herpes virus. It's small, and also it does not have an envelope. So it's a non-envelope virus, okay? And its genome is only 7 to 8 kbps. That's a circular DNA molecule, okay? So I want to get you guys to pay a little attention to the organization of this virus genome. And there are like 8 different genes, okay? So those marked G means early genes. Those are genes that are expressed when the virus start to replicate, okay, during the early time of virus replication. Right? So it's called early genes. And also L, and then marked with L means late genes. Those genes are expressed when during the late stage of virus replication, okay. So I want to start with E1 and E2. So these are the two genes that are expressed during the very early stage of virus replication. Okay, E1 is involved as in DNA replication of the virus DNA replication, and E2 is virus encoding transcription factors that promote expression of the other genes. Okay, but it also has it has a dual role. In one hand, on the one hand, it promotes the expression of the other virus genes. On the other hand, it has suppression function on two other early genes, basically E6 and E7. Okay. In other words, when E2 is expressed, the expression of E6 and E7 is inhibited. Okay, or the expression of these two genes, is minimal. This is very important because E6 and E7 virus genes that can drive to the loss of tumor suppressors like p53 and PRB, and that can lead to cancer development, which I will talk about later on. But now I just want you to know that E2 not only promote expression of the other virus genes, but also inhibit the expression of these two genes. Okay, and this is very important for you guys to understand after when I talk about how the virus promote cancer development. E4 is involved in virus assembly and maturation. There's also other genes, E5, and this is also involved in the virus, signaling, etc. But the these genes, okay, L1 and L2, these are two major virus capsid proteins, genes. Basically, these two genes produce viral proteins for the virus, particles formation. Okay, it's clear? Any question?
For what formation did
For the virus genes, and the function of these genes. Any question? Okay, now let's move on. Okay, so far there are over 120 different types, isotypes or isolates of HPV, identified. I think the number is going to get bigger and bigger as we do more research. But what I want to tell you is not all these different types of HPV are harmful. In fact, only a handful of these different types of HPV are pathogenic, actually. When I say pathogenic, means that they can either cause warts or they can cause cancer. Do you guys know what's the difference between warts and cancer? No idea. Okay. Warts basically are just a proliferation, okay, of any type of cells. Okay, when the cells start to proliferate, okay, and they grow big mass, cells, and those are warts. Okay, warts are not malignant. They do not go like cancer cells. They do not metastasize. Okay, they stay well. They initially starts. Basically, those are not real cancers. Okay, it's something that you can treat and can get rid of it. But cancers, cancer basically is they are malignant. Okay, they can metastasize, go from one place to another place, to invade other tissues, other organs. That's why they are so dangerous, right? So warts are not. The warts, it's treatable. You can remove. So some of those pathogenic isolates like HP1, 2, you can call hand warts, foot warts, 8 HPV6 can cause genital warts, So also the most pathogenic, isotopes include HPV16, 18, 55. Those are the most dangerous ones that can cause cancers. Okay. The reason that the different isotopes, they are different in terms of pathogenesis, whether they can cause warts or they can cause cancer, is because their genes, E6, I will go back to here. The E6, E7 genes, okay, of these different isotopes, they are different, not only in terms of structure and functions, but also the ability to inactivate these tumor suppressors. Okay, so for example, those ones that can cause cancer, the E6 and E7 genes, they are more efficient to get rid of the tumor suppressor genes, P53 and PRP, etc. Okay, and those ones that cause warts, they are those two genes in those isotopes, they are less potent to suppress tumor suppressors. And those that are not pathogenic, E6 and E7 genes from those isotopes, basically they are incompetent to suppress tumor suppressors, and that's why they are not pathogenic. Okay. In terms of transmission, basically, yes.
Sorry, just a quick question. When you went to the first slide for the HPV that showed the genome,
Okay.
I just want to make sure I got it right, because were you saying that E2 inhibits the expression of E6 and E7?
Yes.
So if a virus was one of the ones that are less pathogenic or or I should say will not likely cause cancer for HPV, does that have a higher expression of E2?
Yes.
Okay.
Yes, E2 is expressed for all F types, because E2 is important for expression of the other viral genes. Even for the non-pathogenic F types, the E2 is expressed. The difference is because it's the E6 and E7. Those that are not pathogenic, the structure and also function of this E6 and E2 are a little bit different. They are less sufficient to inactivate this tumor suppressor compared to those ones that are more pathogenic.
So it's not whether or not E6 or E7 are made, it's just
Yeah,
whether or not
structure
they're,
and functions.
whether or not they have the function to do.
Exactly.
Okay. Thank you.
Okay.
And then you also said E2 includes the transcription factors that promote expression of genes. What are the genes they're promoting?
Okay. U2 promote expression like is U4 and also the leader genes L2 and L1. Okay. So basically, it's involved in expression of the other viral genes. Got it? Okay. Now, transmission. So, mother to child transmission is possible, but it's very rare. We don't know why. It's not like herpes virus, it's not herpes virus. You can get it through the saliva, but this is a little bit different. HPV accurate, the transmission from mother to child is less common. But sexual contact is the is the major transmission route, and including oral sex and also hands. If somebody has the warts, the hand warts, for example, you try to avoid to have to shake hands because they can pass the virus to you very easily. You can also transmit through blood, but the one thing I want to get to pay attention to is this virus can also be transmitted through shared objects. Okay, so if you have gloves from someone who has this virus, you try to avoid it because it definitely can transmit through shared objects. Okay. So this is a little bit different than herpes virus. I think the reason is because this virus can survive outside of our cell better than other herpes virus, than other viruses like herpes virus. So in the hospital, usually it's a good idea to. I think you guys, it's true for you guys too. It's better to clean your lab coat. You never take your lab coat home. Okay, it's a good practice. Okay, because you never know who's going to use your lab coat. So now I'm going to tell you how the virus infect patient or people. Okay, so the virus mainly infect mucosa or epithelium. Now here is a structure of typically stratified squamous cell epithelium. Okay, because I think you guys are familiar with this structure, right? So basically, when you have a stratified epithelium on the basal layer, you have the stem cell, right? And then you have the differentiate epithelial cells, and then on top you have the more differentiate keratin cells, right? So the virus infects only the basal layer stem cells, okay, in the skull, in the epithelium. It does not infect the differentiate cells, okay, the keratin cells or the different epithelial cells. It only affects the basal layer stem cells. And now I will tell you why, the reason why, okay. And once the virus infect these cells, okay, and you will, later on the infected stem cells will differentiate, and during this differentiation process, the virus is going to start to replicate and make more virus, which I will talk about in the next slides. Okay. So among those cells that are infected, some of the cells will become malignant or more proliferate, which will lead to the development of warts or tumors, depending on whichever virus you have. for those that can cause cancer, like antigen 6, 17 or 18, you are going to have a tumor growing. Or for those that are less pathogenic, that can cause warts, and that's what you're going to see. You are going to see warts. Okay. So, now, why the virus only infects the basal layer of the epithelial cells? And that's because, like any virus, the HPV also requires a receptor, and the receptor is integrin, alpha 6 beta 4. Okay. As you know, integrin is a transmembrane protein. Okay, and so usually, there's several subunits. One is alpha, and the other is beta. So basically, the real receptor is composed of these two subunits, alpha and beta. But there are 18 different alpha subunits and 8 different beta subunits. So different type of cells, they have the different combinations, okay, which make different integrins. Okay, so in the basal layer of epithelial cells, this is the alpha 6 and the beta 4 as the receptor that's made. Okay, and apparently these virus can only bind to this receptor, and that's why this virus only infects the basal layer of stem cells. Okay, not the more differentiated epithelial cells. Now, so how do the virus get to the basal layer? The current consensus is that the virus gets into the basal layer through microinjury. So microinjury happens all the time. You bite yourself or you get a cut, right? So you even don't know when you have a cut or not, but it happens all the time. So the consensus is that the virus get into the basal layer through this cut, okay, and the microinjuries. So once the virus infects the basal layer, usually it takes the virus stay quiescent for a few days. And it will wait until the basal layer cells to start to differentiate. Then the virus start to replicate. Means the virus replication starts. Okay. So it's the replication is really cell cycle dependent. So when so as the basal layer, okay, the virus genes expression is kept minimum when it first gets into the cell. And when the cells start to proliferate, to differentiate, okay, and that's when the virus gene expression starts, okay. And like I said, U1 and U2 are the two key early genes that are involved in virus gene replication and also expression of the other virus gene, right? So in the basal layer, when the viruses start to replicate, U2 and U1 are the first genes that express, okay? So when the cells further progress towards differentiation, and then on the upper layer, you're going to see expression of other genes like the other early genes, and also further you're going to see the expression of late genes and the U1 and the L1 and the L2, those late genes. So when the cells are further differentiate towards the generation of the keratinocytes, I mean the permanently differentiated cells, where the virus replication completes. Okay, so you are going to have a mature virus on the top. Okay. So this is just further summarize what I just said. So in the basal layer, the cell early gene express when the cells start to differentiate. You're going to see the other genes, expression of the other genes, and then on the top, keratinocytes. Okay, you're going to have mature virus coming out of the cells. Okay. So basically, HPV replication is cell cycle dependent, as the cell proliferation and differentiation dependent.
So what marks the change from, so first E1 and E2 are expressed, and then when would the other cells start to become expressed? Or the later ones, like what causes that change, or is it just time?
Actually, I'm not sure. I'm not sure why that happens, but probably has something to do with the cells. Because when the biology expression is probably it has something to do with the internal environment in the cells. Okay. When the cell start to differentiate, the epigenetic microenvironment is different. Okay, it must be just the epigenetic question, because when the cells get to different stages, the microenvironment is different. That may affect the expression of the viral genes. Okay. It has to do with epigenetics, I think. Do you guys want to take a break, or you want to continue and we can finish it earlier? So we can take a break, or we can continue and then finish it earlier. So what do you? Take a break?
Yeah.
Okay, I think it's better to take a break. Yes. So let's continue. Do you have any questions about this virus application, which is cell proliferation dependent? Any question? Yes.
So, when does at what cell layer does E1 and E2 start being expressed?
You mean U1 and U2?
Yeah.
It's a base layer.
Okay.
And a very base layer. Okay. When the cells start to or decide to differentiate.
Okay.
Okay. At that point, these two genes are expressed. Okay. Any other questions?
When the cells on the basal layer express when it starts to
Okay. Let's move on. Different in herpes virus. Herpes virus. When you get infected, your immune system, you get a very strong immune response from your body. Okay, your body is going to produce antibodies, and then your innate immunity is going to kick off to basically handle the viral infection. Usually your body, as far as you're immune competent, you can control the virus very efficiently. But HPV is different. HPV, does not get into the blood very efficiently. It does, but not very efficiently. And also, it has a multiple different strategies to evade the host immune response, and that's why it's quite difficult for us to control this virus actually from the production and spreading compared to herpes virus. Because this virus has multiple strategies to evade this immune response. Okay, as I mentioned, the E2 and the E6, they are oncogenes, right? And expression of these two genes is minimal. That does not mean that these two genes are not expressed. Their level of expression is low, but when the cells are infected, these two genes are still there. It's just the level is very low. Okay, when these two genes, even though the level is low, but they're okay, these two genes can suppress the expression for inflammatory some kinds like interferons, also other inflammatory genes. So that's why they can inhibit the innate immunity and get away from your host immune response. And also, this virus does not get into your blood efficiently, as efficient as herpes virus. That's why you don't see very often the viremia, which means you don't detect a whole lot of virus in your blood. Okay, that's why this virus can, relatively easily can escape the host response. And the other feature of this HPV is, not like the herpes virus. The herpes virus, their genome do not integrate into the host genome. So herpes virus, as I mentioned, once the genome gets in the nucleus, they become a circular, right? They go from a linear to a circular molecules, and those circular molecules they replicate in an autonomous manner, right? And they don't don't integrate into the genome. But HPV is different. HPV genome, although it's also a circular DNA molecule, but it has the potential to integrate into the host genome. And the integration of HPV genome into the host chromosome is completely random, which means it can occur anywhere along the virus genome, and also can go with any chromosome. Okay, it's a completely random event. So I want you guys to take a look. Okay, as I said, the integration is random, but imagine if the integration occurs between any host chromosome and the region where the E2 gene is located. Okay, and that's when you are going to have disruption of this E2 gene. Okay, so basically, when the integration occurs at this area, you are going to see a disruption of E2 gene, which means you will lose E2 gene. The consequence of this is when you lose E2 gene, you are going to have overexpression of E6 and E7, because as I mentioned, E2 not only promotes the expression of the other viral genes, but also suppress the expression of E6 and E7. Okay, so the consequence is you are going to have overexpression of E6 and E7, which inactivates the two tumor suppressor genes, p53 and PRB, and that's when the cells lose its control and become malignant tumor cells, right? Because it lost two tumor suppressor genes. So this slide just summarizes what I just said. Okay, when the integration occurs in this area, disrupting the expression of E2, you're going to lose this gene, and then you are going to have overexpression of E6 and E7. The consequence is you are going to have inactivity of these two tumor suppressors, p53 and PRB, and the outcome is cancer. Okay? Any questions on this slide? Okay. No.
So E6 and E7 they remove the tumor, they inhibit tumor suppressors, right?
Yeah, that's the next slide. So I'm going to show you. Okay. Here is how this E6 and E7 work. Okay, to cause cancer. Okay, basically E6 as an oncogene that can basically it's I don't know if you guys are familiar with proteomic protein degradation process or not. Basically, in our cell we have specific machinery called the proteasome that can target any protein for degradation, right? So E6 and E7, those are kind of like analogs of the cellular, proteomic machinery factors that can target any protein for degradation. So the way for these two proteins to target p53 is PRB is okay. So E6 is can associate or interact with p53. Basically, it can hook p53, okay, interact with p53, and then target when basically direct this whole complex to the proteasome for degradation. Okay, and that's how it inactivates the PV3, okay, because PV3 will be degraded completely once this protein binds to PV3. And that's when you lose the tumor suppressor, okay. As you know, PV3 is one of the most important tumor suppressor in our body. And the loss of PV3 accounts for 1/3 of all cancers, basically. If you look at all cancers, more than 1/3 of those cancers are due to the loss of PV3. Okay, it's a very important tumor suppressor gene. E7, okay, E7 has a specificity for the other tumor suppressor gene called PRB. PRB is basically expressed in all normal cells. In general, it inhibits cell cycle because it interacts with enzyme called E2F. So E2F is involved in cell cycle checkpoint. When cell decide to either proliferate or divide, okay, or not. This is the key factor that determine our cells' fate, okay, to tell whether the cells proliferate or to divide or not. Basically, it controls DNA synthesis. Okay, in a normal cell, okay, the 2F is inhibited by PRB, this tumor suppressor. Okay, so that's usually the cell proliferation or cell division is controlled. It's controlled by these two genes. Okay. Now, if E7 is expressed, it will interact with this PRB. Okay. Basically suppress PRB, and that will free the E2F. Okay. And then the cycle will progress, and that's why you are going to see more proliferation. Okay. So basically, when the HPV integrate into the host genome, and also disrupts the E2 expression, then you have overexpression of E6 and E7. You are going to have basically, loss of both tumor suppressors, PV3 and PRB. Okay, and that's why you're going to have a development of a cancer. You're going to have a growth, a mass like this. Okay. Of course, if the virus are involved is like a HPV 16 or 18, which are highly oncogenic, and then you are going to see tumor. If the virus involved is someone that is less pathogenic, you're going to see probably worse proliferation. Okay. So now I'm going to just show you some manifestation, associated with this HPV. As I mentioned, different types of HPV cause different symptoms, right? Those can, many of them, they can cause warts, genital warts, for example, or hand warts, for example, and some of them are more pathogenic and cause cancers. Okay. Cervical cancer right now, it's almost all, almost all cervical cancer is, caused by HPV. Either it's 16 or 18, or 45. It's almost all cervical cancer is almost caused by this virus. And HPV is also linked to other cancers, to both male and female. Okay, so it's and also relative to you guys, HPV can also cause head and neck cancers, and so this is the head and neck cancer actually is very common, and particularly in HIV patient. And there's a trend, for men to have a higher chance to have this kind of cancer, okay, compared to women. The reason is not very clear, but this is what they say in the clinic. Okay. Also, oral sex is a risk factor for the development of head and neck cancers. Okay. So in terms of prevention, these are the ways to for you to avoid to prevent infection. Okay, diagnosis is right now can do gene tests to just detect the viral DNA or antibody against the virus. These are the tests available. In terms of treatment, if you have the cancer, the procedure for treatment is the same as other general cancer treatment. I mentioned to you guys that HPV has a different strategy to evade the host immune response, but that does not mean that our body does not do anything to counterattack the virus. Okay? In fact, our body still responds to this virus when you first get infected. And the innate immunity is actually the first one that kick off to attack the virus. Even the virus does not efficiently get into the blood, we still, the virus still can get in blood to some level. So our body, once the virus is in the blood, our body will produce antibodies, right, against the virus. And the antibody that you generate usually is something that can neutralize the virus. So the neutralizing antibody can protect us. That's because the antibody can bind to the virus, okay, and then block its binding to the receptor. Okay, so the virus, once you have the protecting antibody, okay, it will block the virus from binding to the target cells. So even the virus, even you have the virus, because of the presence of this antibody, the virus cannot infect your cells. Okay, and this is the foundation for the development of a vaccine against the virus. So far, there are two main pharmaceutical companies that provides vaccine for HPVs. One of the vaccines is provided by Merck. Okay, and this vaccine, can be efficient for preventing HPV 6, 11. Basically, these two are involved in warts, and also they are efficient to prevent HPV 16 and 18, because these two, 16 and 18, this can cause cancers. So this one definitely is good because it can protect, it can prevent 4 HPVs. Okay. And the other company is provided by GSK. Okay. This vaccine is on the efficient for HPV 16 and 18. Okay. And so basically both are available, but I would prefer the first one because it targets more virus. And currently there's also several human trials for new vaccines, and I think it's going to get into the market soon. Those new trials are vaccines that can actually can prevent the infection of more than 8 different H types, including all those types that can cause cancer, and also those ones that can cause warts, okay, genital warts or hand warts, and I think those ones are definitely are the best. So we look forward to they are coming out. Okay, I think those ones will be really good. One thing I want to mention is, these vaccines, they can only prevent the new infection. Okay, so if someone who have already the virus infection, the vaccine may not work. It's not known that the vaccine can be efficient to eliminate the infected, the HIV, the existing HIV infection. It's not well known, but it may work, but it's not probably is much less efficient. In other words, the vaccine cannot eliminate the infection, that cannot cure the HPV if someone is already infected by the virus. It only prevents new infections. So how the HPV vaccine is developed, I want to just spend a few minutes to talk about it because it has something to do with the unique feature of this virus. Okay, as I mentioned, HPV capsid protein L1 and L2. These are the virus structure protein that make the virus particle, right? So these two proteins, they have the very unique feature. That means if you put these two proteins together, they can form a virus-like structure. Okay, so in general, for other viruses, right, you need to have the genetic material, either DNA or RNA, wrapped inside the virus particles, right? So, in other words, in order for the virus to mature, you need to have both the genetic material and the virus particles together to become infectious particles, right? But for HPV, it's different. It's very unique because the virus capsid proteins can form this kind of virus particles without the virus genetic materials. Okay, so this kind of a pseudovirus is the basis for vaccine development because we can easily express this virus L1 and L2 proteins in a in vitro system. Okay, and then we put the protein together, and then we can have pseudovirus like this. So basically, the pseudovirus is what we use as a vaccine for the as a vaccine. Okay, a vaccine for the So basically, the vaccine is very safe because there's no virus DNA inside. So even though they're infectious, they cannot cause any harm because there's no DNA inside the virus. Any questions so far? Okay, let's look at. I think this is probably we probably come to the end of the lecture. So right now I'm going to come back to the questions that when I studied. I show you these different pictures, and I'd like to know how well you learn from these lectures. See if you guys can tell now which one is which one.
E is cold sore, C is not cold sore.
Anyone can tell me? Let's see.
I think they're in order.
Yeah, they're
Any order.
E is compulsory sarcoma.
G? Yeah, G is compulsory sarcoma, okay.
It's warts.
I think it's what?
D is leukoplakia.
Oh, let's go one by one, okay. A, which one is A?
Canker sores.
Canker sore. Haha, no. You have learned this from Tim's class, right? A should be, or mouse also. You go back to check with Tim.
So,
Mouse also is usually as a trauma, right?
Okay.
what's C?
C is the
Okay. Let's see. B. What's B?
cold sore.
Cold sore.
Good. What's C?
Canker sore.
Canker
Right. You got it. And then D.
sore. Leukoplakia.
Great. And E is compulsory sarcoma, right? And
What?
Warts.
warts. Yes.
What's the difference between canker sore and the mouth ulcer?
The ulcer is usually, I think, is because of trauma. You bang yourself or something like that, I think. And canker sore, it has something to do with when you have a stress, when you get some kind of bacterial infection. I think it's, I think the reason, the real reason is not well known, but usually has something to do with infection. Okay, and the ulcer can occur when you have I mean, it's a drug. When you sometimes when you eat some kind of diet or some food, particular food, you can get this too. But I want you guys to go back and ask Tim. I think you should have. I think he should have talked about this. Okay. Basically, they are not associated with virus infections. Okay. But the other four, they definitely are associated with virus infection, right?
What are some landmarks that we can look at between the mouth ulcer and then the canker sore to be able to differentiate them?
Again, I want you guys to ask Tim.
Just ask him.
Yeah.
Who is Tim?
Tim, I think you have his lecture?
What's Tim's
Tim,
last name?
His last name.
Like,
When you talk about the glucose, sugars, this kind of stuff,
He's talking about just in
PBL.
PBL.
Oh, he does
okay.
it class?
No, this is PBL of like,
FLS.
yeah.
The one had to tattoo?
Yeah, we didn't talk about
I forgot his name, last name. I used to PBR for him. He's the I think the course director. Because I used to do PBR for him. And I think there's at least one or two lectures that he especially talk about this kind of manifestation.
Okay.
Yeah, maybe you should come back and ask him. He's the expert. Okay, but I know this kind of things usually occurs when you have a trauma. When you bite yourself or eat some kind of food, okay, and you're going to get this on your lips or on your cheek. Do you remember? And the kind of this one is usually because you have stress and you get some kind of bacterial infection. Okay, and this is why it's a canker sore. Okay.
Okay.
All right. Now I'm going to give you a quiz and see how well you really did from this talk. So the first question is, which of the following statement is correct? Okay, you have 4 or 5 answers to choose. Okay, you guys take a look and see what's the best answer. So the first answer is Mendelian virus are allergenic. Is that true or not? Okay. The second, most DNA virus cause chronic and persistent infections. True, right? And C is all DNA viruses have a large genome. That's false, right? And D option is not correct. So the correct answer is yes. Question 2. Certain DNA viruses have an amino. And what is the origin of virus amino?
cell membrane.
Eh?
The cell membrane.
No. The capsid proteins.
No. I remember I said this multiple times. Okay, the membrane comes from the cells, right? So when the virus is formed and trying to get out of the cells, it will acquire the cellular membrane and then get out of the cells through exocytosis, right? So basically, the virus amino comes from the cellular membrane. So when the virus gets into the cell, and one way for the virus to get into the cell is through fusion, because the virus membrane and the cellular membrane are the same, so they can fuse. So then through fusion, the virus can get into the cells. Remember? Right? So the correct answer is cellular membrane. Now, question number 3. Which of the following risk factor for reactive latent herpes virus.
T.
Oh, God.
Yes, correct. So immunosuppression definitely is a contributor. Stress, other infections, inflammation, and also there are a whole bunch of different stimuli that can cause herpes virus reactivity, right? And question 4. Herpes simplex 1 or HSV1 belongs to alpha herpes virus family because it can infect neuronal cells. It has the relatively small genome. It replicates faster and it causes cancer. So, yes. The classification of herpes virus is based on what kind of cells they have. Okay. 5. Which of the following statement is not correct? A. Epstein-Barr virus is associated with hairy leukoplakia. True or right? False?
True.
Yes. B. Kaposi sarcoma herpes virus is associated with Kaposi sarcoma and several types of lymphoma. True. C. Herpes simplex virus 1 causes oral infection.
True.
D. Herpes virus simplex 2 only infects genital area.
False.
Yeah, so as I mentioned, these two herpes viruses can go either way, okay? Question number 6. Which of the following statement is not correct again? So, 1. Varicella zoster virus causes chickenpox in children.
True.
Varicella zoster virus causes shingles.
True.
C. Different than chickenpox, shingles most often is restricted to certain zones and affects only one side of the body. Yeah. Chickenpox and shingles are caused by different strains of Wisili. Yeah, that's wrong because shingles is caused by the same virus that you first get. It's due to the reactivation of the same virus. Okay. Question number 7. Which herpes virus causes Burkitt's lymphoma in children? Yeah, Epstein-Barr virus. Okay. Now, number 8 question. Number 8. Which herpes viruses can be transmitted from mother to children through saliva? Yes. So contact is the main result for herpes virus transmission, and transmission, and basic saliva, is the main as a media for contact transmission. All right. So for your final exams, so these are the questions. These are the kind of questions we are going to see. Okay. So now I think that's the end of my lecture. So if you guys have any questions or suggestions,